All right, hello, ladies and gentlemen. Um, this is lesson 2.5, quick linear graphs. And we have three different types of models that we use for graphing. So one of them is the slope-intercept form. So hopefully you know slope-intercept form. Y equals mx plus b. We'll talk more about that. Another one is standard form, and we use standard form to find the x and y intercepts. And then the last one is point slope form. And I use point slope form all the time. And in fact, in higher levels of math, we rarely talk about anything else but point slope form. So this is the one that you really need to know. And if you don't have it memorized, you're going to want to memorize it. You have IXL skill D7 today. And again, do you see your name? You want to get an 85 or better, but really you can stop whenever you feel good. All right. Let's see. So again, you might want to pause the video and write stuff down, which is really easy to do. And so this is basically just a summary, and we're going to talk more in depth about each one of these different forms. So there's going to be more examples coming, but this is going to be just a real brief example page. So go ahead and pause the video and write this stuff down, and then I'm going to talk through these things as well. So pause the video, write it down, and then press play when you're ready. Okay, so we are looking at how to graph lines, and we have three different forms. And these are three really important forms that we want to make sure that we know how to use really well. So slope-intercept form, standard form, and point slope form. And they're sort of generic models that we use when we're graphing, but also writing equations of line, which is what we're going to do next. So first of all, hopefully you're very familiar with slope-intercept form, y equals mx plus b. And this is how you can plot it. To graph the line, you're going to plot the point 0b. So whatever this value is on the end that doesn't have an x next to it, you're going to plot that, and then we get to count the slope just using rise over run. So here's an example. I have this equation, and you can see that it's in slope-intercept form. I'm going to write that down right on top of it, y equals mx plus b, so that you can really see how everything just sort of lines up. And paying attention to how things line up is really, really important. So the first thing we want to do is plot 0b. So you can see that my b lines up with my number 3. B means begin here. So we have the point 0, 3 that we're going to start with. I'm going to make a little sketch here. Chicken scratch graph is what I call this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And you can do this on your paper too. Really easy, really fast. This is all we need to do. Don't spend hours making this super perfect graph. We have 0, 3. Our B is 3. They line up. So we're going to have the point 0, 3 is where we begin. So 0 for the x and 3 on the y is right here. So this is the point 0, 3. We're going to make a nice big starting point. B for begin here. All right. And then you can see the slope is the number in front of the x. And so you can see the x's match up. The m is equal to negative 1/2. All right, that is the slope. So the slope is negative 1/2. And that tells us to go down 1 and run 2. So I always put the negative with the top number, and I'm going to go down 1 and to the right 2. Down 1 to the right 2. And just make a couple of dots. And I think on IXL, you just have to do that once, and it'll give you this gorgeous line. So that's really kind of nice. And that's all we're doing. We're going down 1 space and then right 2 spaces. Little stair step. Down 1, right 2. That's it. So slope-intercept form, really, really easy. We also have standard form. Standard form, A, B, and C are going to be numbers like 2, 5, or 7, maybe negative numbers, okay? And then you can see that X and Y are on the same side of the equation. Here, you can see that the Y and the X are separated by the equal sign, okay? So here we have standard form, and you can see here's an example. We have the X and the Y on the same side, and whenever we have standard form, what we want to do is make a really quick table. And I do this by hand. I'll just write like X and Y, and we want some zeros as placeholders. And that's exactly, it's telling you what to do. And we want to figure out, hey, what goes, if I plug in a 0 for X, what goes in place of the Y? So I'm going to do that. I'm going to use some colors here. So we sort of have to do two things. So here's my equation, and the first thing I'm going to do, it says take 0 and plug it in place of Y. Sorry, not Y. Take the 0 and put it in place of the X. So I'm going to go to my equation, and I'm going to put a 0 right here in place of the X. And I'm going to do this in blue. So that's going to be 3 times 0 minus 5Y equals 30. Well, what is 3 times 0? Well, 0. It goes away. So now I'm left with negative 5y equals 30. And how do I get y by itself? I'm going to divide by negative 5. So I get y equals 30 divided by negative 5 is negative 6. So when x is 0, y is negative 6. And now I've just found an ordered pair that I can plot really easily, 0, negative 6. All right. I'm going to do the second one. You can see it's saying, hey, y in this case is going to be 0. So I'm going to do the same process again, but I'm going to put in a 0 for y. So go back to my equation, 3x minus 5, plug in a 0, equals 30. So I'm plugging in a 0 this time. Well, what is 5 times 0? 0. It goes away. We don't care about it. And I'm left with 3x equals 30. And how do you get x by itself? Divide by 3. We get x equals 10. So that one is the ordered pair 10, 0. Now here's the really great thing about graphing this one. I don't even care about tick marks. I'm going to go ahead and plot the point 0, negative 6. That's 0 on the x-axis and down 6. So right here is the point 0, negative 6. Label your point. And then 10, 0 is my second point. So that's 10 on the x-axis is way over here, 0. So we're plotting the x and the y intercepts. And then once you plot your y-intercept right there where it crosses the y-axis, that's the y-intercept. And I'll write that down actually, it's really important. That is the y-intercept. T-E-R-C-E. Oh, intercept. C-E-P-T. There we go. And where our point crosses the x-axis is the x-intercept. Once you get those, then you can just connect your points. And you get a beautiful line. There it is. It's a great way to graph. Just plotting intercepts. All right, and the last one is point slope form. And again, this is kind of an interesting form. It comes from the slope formula. You can imagine if you had x2 minus x1, that's very similar. This actually was y2 minus y1. It is exactly the slope formula and just rearranged a little bit. So we have the form here. This is your point slope form. I'm going to go ahead and write it above. Y minus y1 equals m times the quantity x minus x1. And so you're going to notice sometimes the signs are a little different. So you have to be very, very careful. It says we're going to plot x1, y1. So I'm going to find those. Well, here's x1. But you'll notice that we have a negative sign, and this is a positive 1. It's kind of weird. So I'm going to write something a little bit different. I'm going to rewrite this as well. Let me, y subtract 2 equals, so I want to make my signs look the same. X, instead of a positive, well, it's really minus a -1, right? Negative times negative, we would change to a positive. We'll get better at this, but now you can see the x's match, that negative sign matches, and now we see that our x1 is actually -1. So we have the point -1 for the x value, and here's our y1 right there. We see those negatives matched. So y is the 2. So we're going to go ahead and plot that point to start. So here's -1, 2. I'm going to go ahead and make my little chicken scratch graph. All right, so I'm going to plot my point -1 up 2. So there's my starting point. And then I can count the slope. So I want to figure out the slope. So then count the slope. Well, right here, m is 3, right there. M is 3. Well, I need a fraction in order to do rise over run. So we turn it to a fraction by putting it over 1. And it's a +3, so it's telling me to go up 3 and to the right 1. So starting at my first point that I plotted, I'm going to count up 3, and I didn't quite make my graph big enough. I'm going to go up 1, 2, 3, up 1, 2, 3, and then to the right 1. So there's my little stair step for slope, and I can connect those with a nice straight line. So that is just the fast way to do that, and I'm going to talk more about these in the next examples. So we're going to take our time here. I'll explain a little more in depth. So example 1, graph the line. So the first thing you need to figure out if you're going to graph a line is which form are we in. So I can see that the y is by itself, and so I'm thinking right off the bat, well, that's y equals mx plus b. And I'm going to write that down. You'll notice I stacked it up so I can see which things are lining up. And so this is slope-intercept form. And the first thing we want to do is figure out our beginning point. Where do we begin? We're going to begin at the point 0, 1. Always 0 and then the b, whatever that b value is. I'm going to go ahead and make a little chicken scratch graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. Real easy, quick graph. And then I'm going to plot the point 0, 1. And that is where I begin. Put a nice big dot there. And then after that, then we're going to count the slope. And so we know that the slope is 1/2. And that's telling me to go up 1 unit and then right 2 units. The top number, it's going to go up or down based on the sign. But the bottom number is always going to go to the right. And I don't know if, I'm not sure which way you're saying that, but to the right. So we're going to go up 1, right 2 spaces. Up 1, right 2 tick marks. Okay, and that's it. That is graphing a line in slope-intercept form. Let's try one more. Again, the y is by itself. So that matches up with y equals mx plus b. Oh, maybe I should have written that a different way. What if it was y equals 4 minus 3x? What if you saw it that way? That's not in the right order, is it? So you have one term -3x and you have another term that's a 4. Well, it's a +4. There's no sign there. So then you can rearrange those little bubbles however you want. So if you saw them and they were out of order, you could rearrange those terms so that they're the way you want them. Okay. All right, begin. Where do we begin? We begin at B for begin, 0, 4. So I'm going to make my little chicken scratch graph. And I'm going to plot my beginning point, 0, 4. 0, 1, 2, 3, 4. And then I can see my slope Your slope never includes the x. The x is x. It lines up with x. The m is slope, and it lines up with the -3. So our slope is -3. Again, is that a fraction? No. So I can simply put a 1 under it, and now it's a fraction that I can plot. So this is telling me, because it's a negative, we're going to go down 3, and then always to the right. Whatever the bottom, whatever the denominator is, it's always to the right. So we're going to go down 1, 2, 3, and right 1. 1, 2, 3, and right 1. And I'm going to use my straight edge. And there it is. This is a negative sloped line, and our slope was negative. Here we have a positive sloped line, and our slope is positive. Okay. All right, again, the first step is figuring out what form the equation is in. And so when I'm looking at this form, I can see that the x and the y are on the same side. So that matches up with standard form. So ax plus by equals c is standard form. And for this technique, we are going to make a quick chart where we plug in some zeros for x and y. All right, let's see what happens when we do that. I'm going to go ahead and make my little sketch graph here. Don't make your graphs too small. Small doesn't help your graphs. All right, so the first thing this is telling me to do, it says make x a 0. So I'm going to take my equation and I'm going to make x become a 0. So that's going to be 2 times 0 plus 5y equals 10. Well, 2 times 0 is 0. It goes away. We're left with 5y equals 10. And then how do I get y by itself? Divide by 5, so we get y equals 2. So when I plugged in a 0 for x, I got a 2 for the y value, and that is a point that I'm going to plot on. 0 for x, 2 for y. I'm going to plot that on my graph. All right, the second thing, it says, hey, make a y turn into a 0. So I'm going to go back to my equation, 2x plus 5, and instead of a y, we're plugging in a 0. Well, what is 5 times 0? 0. That leaves us with 2x equals 10. We're going to divide both sides by 2, and so we get x equals 5. 10 divided by 2 is 5. So that is my second ordered pair. X is 5, so here's our x-axis, 1, 2, 3, 4, 5. 0 for y, 5, 0. And those are your y-intercept and x-intercept, and we can just connect the dots. 2 points determine a line. So when you have 2 points, you have enough information to draw a line. All right, that's pretty fun. Let's try one more time. Again, the x and the y are on the same side, and I often have students who are like, if this is supposed to be ax plus by equals c, well, what's the a value? What's the number in front of x? It's a good question. Remember that x really means 1x, all right? 1x versus here we have 2 x's, here we have 5 y's, all right? So keep that in mind. That's a good question. All right, we're going to plug in some zeros for x and y. So I'm going to start, and this little chart is telling me, hey, if x is equal to 0, what happens? So let's go to our equation, and we're going to have 1 times 0 minus 2y equals -8. Well, what's 1 times 0? 0. It goes away. We're left with -2y equals -8. And then to get y by itself, we're going to divide by -2. -2 divided by -2 is 1. It reduces away. Negative divided by negative is positive 4. So there is our first ordered pair. So 0, 1, 2, 3, 4. Oh, I didn't color code it. That was supposed to be green. Oh, man. All right, green, 0, 4. All right, I like color coding. I just think it makes notes more fun. All right, my next thing says, hey, turn that y into a 0. So let's go back to our equation. We're going to turn the y into a 0. It's like magic. 2 times 0, or in this case, negative 2 times 0 is 0. It goes away. Leaves me with my 1x equals negative 8. You don't have to divide by 1, but even if you did, don't you get the same thing? X equals negative 8. I don't have enough tick marks. I'm going to extend my graph. 5, 6, 7, 8. So I'm going to plot my point, negative 8, 0. I always label everything. And again, you didn't actually have to do tick marks on these, but I think in IXL you will. If I had simply done, hey, this is negative 8, 0, and this is 0, 4, and then connected my dots. Oh, sorry, I'm crazy here. There you go. That also is wonderful. There is nothing wrong with this very, very simple graph. It's wonderful. All right, moving along. All right, this one is probably the most different, and you probably haven't seen anything like this. So this is, you can see we have y minus something equals a grouping symbol thing. So this is point slope form. And so it matches up with y minus y1 equals m times the quantity x minus x1. So on this one, again, the thing we want to start with is we want to plot x1, y1. We need that first ordered pair. I'm going to go ahead and set up my graph. All right. So I need to figure out what x1, y1 is. So I'm going to look at my original model. And there's my x1. And I just want to make sure everything matches up like it should. The x's match up, the negative, the subtraction sign matches up. And so in this case, the x1 is simply 1. And then y1, again, the y matches up, that subtraction matches up. And so it looks like y1 is really 3. So we're going to plot 1, 1, 2, 3. And that's going to be our starting point. And then I want to find the slope. So again, what matches up? We want to find m. Well, our m is right here. Our slope is negative 2. And again, I want that as a fraction. So I'm going to put it over 1. So it's a fraction. And then that tells me negative 2 says go down 2. And the bottom number tells me always to go to the right. Down 2 over 1. So from my starting point, I'm going to go down 2 spaces or down 2 tick marks and then over 1. Down 2, right 1. And that's a good graph. This is not the only way you could do it. You can convert this very, very easily by distributing and moving the 3 over. So you can isolate y if you wanted to, but I do want to show you how to do it this way. This is interesting, isn't it? Doesn't quite look like any one of our forms. So it maybe if we didn't have grouping symbols, maybe we would want to just distribute and use slope-intercept form because the y is by itself. So that's an option. So I'm going to go ahead and just do that on the side here. If I were to distribute the 2/3, 2/3 times x is 2/3 x. And then 2/3 times 3. 2/3 times 3. That's 3 over 1. And we go straight across. That's 6 over 3. 6 over 3 is 2. So this is 2/3 x plus 2. So you could graph using slope-intercept form. But I'm going to graph this using point-slope form. So I'm going to write down my point-slope form model. Y minus y1 equals m times x minus x1. And I'm going to see, it's very interesting. I can rewrite this formula. I have the y, sure, but I don't have this thing, y1. That's because it's a 0, all right? And so we would never write zeros, right? It's useless, it's boring, it doesn't help. So that's why there's nothing there. But we can put it back in and use it as a placeholder. We have our 2/3. We have our parentheses with the x. And then again, this is a plus, so I'm going to extend that and make it minus a -3 because I want to make sure that I have a negative. And again, we would never write things out this way. Mathematically, we just don't do it. But for our sake, I need you to for a little while. Maybe you'll realize it's just the opposite, but that's okay. So now my formula, which looked like this originally, and all I had to do was make a few adjustments. Now I can see that my point that I'm going to plot, x1, y1, is, here's my x1. Again, the x's line up, the subtraction lines up, and now our x value is -3. It was +3, we use -3. And then the y1, again, the y's line up, the subtraction lines up, and here, y1 is equal to 0. So our starting point is at -3, 0. So -3, 0 is right here. That's where we're going to start on the x-axis, 0 for y. And then we're going to count our slope. And what's lining up with this slope is 2/3. It's a +2. That tells you to go up 2, rise 2, and run 3. Run to the right, always to the right. So we're going to go up 2 and run 1, 2, 3. Run up 2, run 1, 2, 3. And that's a great line. Okay. All right. So know that you can distribute and combine like terms if you want to rewrite it in slope-intercept form is totally allowed. Little extra work maybe, but last thing, I promise, this is it. These are special case lines, and I really like to talk about special case lines. Here you see we just have y equals a number. So these are special cases. So we have just y equals a number. And anytime you have y equals a number, it is simply a horizontal line. Okay. Let me talk about y. Horizontal line. So what it's saying is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, first of all, -3/2 is weird. A lot of students think when they see a fraction, they think slope and they're going to count it as its rise over run. But that is not the case. Y equals -3/2 is really y equals -1.5. It is simply a number. It is not slope. It is just a number. So it's saying, hey, go to the y-axis and go to -1.5. Right there is -1.5. And if you were to plot this point, the point is actually 0, -1.5. So it turns out that I can plot all kinds of points. Like this one right there, that point is 1, 1.5. Next door would be 2, -1.5. 3, -1.5. 4, -1.5. 5, -1.5. And so it turns out that when we're plotting points along this horizontal line, I'm gonna sneeze. The y value all along this horizontal line, the y is always -1.5. And that's really important because that's actually very, very specific. Every single point, and there's an infinite number of points on this line forever, an infinite number of points. The y value is always -1.5. And well, mathematically, that translates to y is always negative 1.5. And so it's actually such a simple understanding of writing an equation of a line, because it really literally translates to y is always negative 1.5. Do I care about the x value? No, the x could be anything you could ever dream up. But the y is negative 1.5, and it will fall on this horizontal line. Well, if y equals a number is a horizontal line, then x equals some number must be a vertical line. And again, the same thing holds true. So it's saying, hey, go to the x-axis and go to 4. And so we have the point 4, 0, where the x value is 4 and the y value is 0. The same thing is true if I go up here, up 1 point, then that's going to be 4, 1. And if I go up again, another point would be 4, 2. And up again, that would be the point 4, 3. And again, on this vertical line, forever down and up, every point on this line is going to have an x value of 4. And so again, this is saying the x value is always 4. And if the x value is always 4, that literally translates to x equals 4. We don't care about the y value. The y can be anything you want, any number you could possibly imagine. As long as the x is 4, it's going to fall on this vertical line. So it's really, really a perfect description of a vertical line. So 2 really good things to know and understand. All right, hopefully that is a nice review of graphing lines for you. And you can go and do your best to get an 85 or higher for some extra credit. Have a great day.